Myself Shobhashachi Ghosh, an instructor of Government IT Input, Department of Fitter.
Today I am going to discuss the anatomy of oxyacetylene gas welding flame, or about the chemical reaction that produce such a lucrative and illuminous flame. Chemical reaction takes place as shown in the screen. Here we can see that in general, for proper combustion of every volume of acetylene, 2.5 volume of oxygen is required. But actually, the chemical reaction between oxygen and acetylene takes place in two stages. First, we look into the stage 1 of two-stage combustion process. Here, acetylene reacts with oxygen and form carbon monoxide and hydrogen and release intense amount of heat of order 448 kJ per mole or 18.75 megajoule per meter cube or 1500 BTH waste heat for every cubic feet of acetylene, which is 1/3 of total heat generation. And it causes the generation of a temperature of about 3050 degrees Celsius to 3450 degrees Celsius, which is used directly to melt the steel joint. Most importantly, this first stage is responsible for the formation of inner white cone of oxyacetylene gas welding flame. Oxygen required for this stage is obtained from oxygen cylinder. Now come to the second stage combustion, where the carbon monoxide and hydrogen that produced as a combustion product in first stage combustion reacts with atmospheric oxygen and finally results into the formation of carbon dioxide and water. This second stage reaction is responsible for the formation of outer bluish flame. This second stage produces 812 kJ per mole or 35.77 megajoule per meter cube of heat, and 1200 degrees Celsius to 2000 degrees Celsius of temperature is obtained due to it. Heat generation in this stage is 2/3 of total heat generation in oxyacetylene gas welding. If we compare those two stages, we discover a magical fact, that is, in spite of higher amount of heat is generated in second stage combustion, but it produces less temperature than that of first stage. This is because of the distribution over a wider area of second stage or the outer flame than the concentrated first stage heat that enclosed in inner cone. For this reason, the heat produced in the second stage combustion is only used for the preheating of steels, where the heat produced in first stage combustion is directly used for the melting of base metal. So from this discussion it is clear that those two stages are responsible for the formation of two distinct flames, that are the inner cone and the outer cone. And the oxygen required for the first stage combustion is only provided by the welder from its oxygen cylinder, and the oxygen required for the second stage combustion is obtained from the atmospheric oxygen. And for this reason, the actual volume of oxygen required for the combustion of each volume of acetylene is also a single volume. Now we look into the advantages and disadvantages of two-stage combustion process. Two-stage combustion is the strength as well as the weakness of oxyacetylene gas welding process at the same time. Advantages lies in the fact that the products of combustions are reducing in nature and providing not only excellent protection of weld pool but also reduce, at least in part, the oxide present on the surface of the rod and the base metal. And the disadvantage lies in the fact that the total heat generated in two stages. First stage combustion, which is effective stage for the purpose of welding, produce only 1/3 of total heat produced in the oxyacetylene gas welding, and the remaining 2/3 heat is produced during the second stage combustion. when carbon monoxide and hydrogen that are produced during first stage combustion burns into the atmospheric oxygen. So only a small part of total heat is utilized for the purpose of welding. This was the detailed study of formation of different flames of oxyacetylene gas welding. In our next video, we definitely cover different types of flames produced in oxyacetylene gas welding. Thanks for watching. Have a nice day.